Okay. Is discuss the payload and deployment of.
Okay.
But I think the rocket's pretty straightforward from everything I'm seeing. So,
Okay.
if I can ask one real quick question, I noticed that you referenced that you were in 30K COTS last year. Is that correct?
10K.
10K COTS last year. Okay. Are any of the team members that were in the 10K also members of this team?
Me and AJ both are.
Okay. All right. All right. I see Elaine and Leo are here for my team. When you are ready, we're
Okay.
ready.
Kelly, can you give me sharing permissions? Or if AJ can share. Oh, I can. There we go. Okay. You guys can see that screen?
Yes, we can.
Okay. So we are Idaho State University's ME Department Space Initiative Club. We are Team 33 for this year's spaceport competition. So the rocket specs for this rocket will be the height of the rocket in total will be 10.4 feet. We'll weigh in around 70 pounds. We'll have a center of gravity of 79.172 inches and a center of pressure of 90.143 inches with a stability margin of 2.13. And we are going to be using a O motor, the 3400 Accessoroni motor. So we did simulations on OpenRocket and RAS-Aero. The graph on the right is the RAS-Aero simulation of the 31,895 feet for our max altitude. The propulsion specs of the rocket, we have an average thrust of 3416.7 Newton seconds. We have a max thrust of 4,750.3 newtons with a total impulse of 21,362.2 Newton seconds. The motor has a burn time of 6.16 and a thrust to weight ratio of for the rocket to motor of 14.1. We'll have a launch rail departure velocity of 124 feet per second with a max velocity of 1,997 feet per second. And we'll have the electronics in the rocket itself will see a max acceleration of 16 Gs. So for our recovery systems, the drogue's descent rate will be 77.63 feet per second. We know that's pretty low, but we're trying to save money for building this rocket as we're kind of a smaller school in this. So we're reusing our last year's drogue parachute, which is why that number is so small. But that will be deployed at Apogee, and we'll be using black powder charges to cause the separation event. 2 of those at 4 gram apiece. The mains descent rate will be 16.1 feet per second and will be deployed at 1,000 feet, and then there will be a backup altimeter at 800 feet. And then those will also be that separation event will occur with black powder charges as well at 4 grams a piece. And then when the payload separates from the rocket itself, it will be traveling at a speed of 24.8 feet per second. I'll let AJ talk about the Avionics Bay as he used the lead for that.
The electronics that we are using in our Avionics Bay for this year mostly rely on the electronics we've used for our last year entry for a 10K. We're using the MissileWorks RRC3 Sport altimeters. We have a main and a backup and external switches for those. And we are also using the featherweight tracker for our GPS. We were able to track it very well last year, and the tower was able to track it very well as well. You can probably go to the next slide. So here's all of the electronics. I'm sure that you're familiar with how they look. In addition to the electronics I mentioned, we are also using a tender descender to separate our payload from our rocket. We've done tests of our tender descender, and I think we'll move on to talk more about the payload on the next slide. No, it's fins, and then it's construction. So this is back to Cooper, but the whole team kind of helped with this. Cooper kind of headed this as the lead.
So yeah, I guess the airframe of our rocket, we'll be using a 5-inch diameter rocket. The rocket itself is made completely out of fiberglass. That material selection was mainly due to cost, as we couldn't really afford the to make it out of carbon fiber. We'll be using 4 fins spaced 90 degrees apart. The fin thickness is 0.187 inches. I forgot to put inches in there of G10 fiberglass. And then once those were slotted in, we had 4 layers of 6 ounce per yard fiberglass cloth put onto those with 2-part epoxy. The rocket also has 2 couplers, each coupler being 10 inches long. One being used for the eBay and the other one as an extension piece for the lower airframe, as the motor is quite large and we only could buy up to 5 feet long fiberglass tubing commercially, so we had to add an extension piece to be able to fit our main parachute into place. With the fin design last year, we learned a little bit about fin flutter, and so we wanted to try to avoid that issue this year. During our safety inspection last year. So we used these following equations to calculate our fin flutter, as well as the Excel spreadsheet that we received last year to calculate what fin flutter would be. So our fin flutter for this year is 2,423 feet per second. And since our max velocity is 1,997 feet per second, we have a safety factor of 1.2 for our fin design. So I think the next slide will be the payload. Ben was the lead for that, and he can talk a little bit about what the payload was like.
Yeah, so here's the payload. The idea behind this was that we had the legs, the landing gear at the bottom. The idea for this was that it kind of acts like a parachute, so that they can fold out and then they can take part of the impact and,
Well, like a landing gear.
yeah, like a landing gear, yeah. And then the electronics are actually the same as for the Avionics Bay. We have the featherweight and the run cam, and with this we're trying to get footage with the run cam for the separation event and the descent of the lander.
And that's the final slide. We wanted to turn it over to you for questions and also showing you the physical body of the rocket. Cooper had a video, an image on his slide. It looks just a little bit different from that now. It's been painted a little, and we can show you the ins and outs.
Okay, let's go ahead and do the review of the rocket first.
Okay.
I think also within the payload, there'll also be a electronics sensor to see how much G-forces the payload sees during flight, to see if that matches what the simulations say.
Okay, we'll circle back around to the payload here in just a second.
What do we want to show first?
If your volume's on, Cooper, you sharing your screen so that they can see your mic.
Very good.
Okay.
Ooh, that's one. Okay, so
We have
that's
the lower section here. And this is that fiberglass section that you saw in the image with our shock cord. But we currently have something testing on the deployment of the parachute.
okay. Are you reusing your shock cords from last year?
When we get all this out.
We are. We have one new shock cord for the upper airframe section.
Okay, can you go back and make Mike appear? There we go. Okay, and the black is really a fiberglass tube, correct? Not
Yes. I don't know how to turn up my volume.
and you're using an aero pack retainer?
Yes, that is correct.
Okay, back to Mike.
Okay,
Um,
Lee Oleanick would like to control your camera. What does that mean?
No, I tried to make it to pin it and I clicked on camera, so please ignore that.
Oh,
Sorry.
um,
Mute that one.
Okay.
okay, so we noticed that well, we need to improve these. Yeah. It's kind of difficult to talk when there's like a slight delay to hearing my own voice.
Yeah, that's okay.
Mike fixed his volume. We're good now. So this is some shot cord that this is some rope that we used on our 10K. We were going to be replacing this with more Kevlar tubing.
Okay.
That looks like this. It's 1/2-inch wide segments, but we'll be replacing it with that Kevlar.
Okay. Elaine, are you okay with that? Yep, I guess that's okay. Go
I
ahead.
was muted. I was muted. How long is it?
So this is 40 feet, and this goes between the main parachute and the base of the rocket and the avionics bay. I suppose that we have a couple whiteboards here. There was also a graphic that I thought was on the presentation, but I guess it's not. But yeah, this is 40 feet long, and we can make it longer when we replace it with the Kevlar tubing. Like we have.
How tall is your rocket?
Our rocket is
10.5 feet.
yeah, almost 11 feet.
Okay, so is that between just two of the sections, or is that in segments and part of it goes between the booster and the avionics bay and part of it goes between the avionics bay and the nose cone?
So this is only between the avionics bay and the base where the motor is. We have another segment.
This falling segment is 21 feet long.
And this is out of the same Kevlar tubing that we plan to get for the base. And yeah, as Cooper said, this is 21 feet long.
It should be about the same length as the other one. You could get another 20-foot section and couple them together.
Yes, so
Why do you say that?
Why do I say that?
Yeah, this is Greg Spahn. I'm the L3 for this project.
Okay.
I've never heard of that being.
You never heard of
practice.
getting two different tubes, two different cables, or you never heard that it should be 3 to 5 times the length of the rocket? Which part have you never heard?
That the two should be about the same length. So are you saying that they're too short, or that I'm confused about what your advice is.
The second one, it sounds like it's too short.
So you would want a 30-foot, not a 30-foot section of tubing, not a 20-foot section of tubing for the second one, while we have a 40-foot section for the other one.
What do you think, Ben?
Well, number one, I think for the payload for the nose cone section, I think 20 feet is a little short. Whether it's 30 or 40 is, I guess, debatable, depending on how you're doing your payload and so on and so forth.
okay. Okay,
So we need to increase the length of this one.
that's they're saying for the total length. We can use a segment. So you said that 3 to 5 times the length of the rocket is preferred for
Yes.
Yeah, that's basically a rule of thumb.
Yeah.
So is that that is per chord, correct? Not total. Since for each
Yes.
chord, since we have between the nose cone to a here.
Hey, Cooper, do you want to maybe pull up that that graphic? Do you want to pull up that graphic and show that on your screen? That'll be better than me grabbing pieces.
Yeah, I can. One sec.
Okay. I feel like it'll help give a more complete picture of the different events and what the rocket looks like at each stage.
On your cords, it's, oops, I'm muted.
No, you're not.
No, we can hear you.
Okay, just, you know, when you go through safety check, as I'm sure you're aware of, since you were there last year, in Las Cruces, they will check for such things as burn marks and stress marks and stuff like that on the shock cord, whether it's Kevlar or nylon or whatever. So just be aware of that if you're using used cord.
Okay, we are aware of that.
Okay.
This cord is not planned on coming with us. This white cord is not planned on coming with us to Las
Good.
Cruces.
Good.
This is only for our deployment testing for now.
Gotcha.
So here's the
Okay, so do you-
graphic that
Ow.
AJ keeps referring
Yeah.
back to for the mission.
Can you zoom in a little bit?
Yeah, one second. Maybe not. Hold on.
Yeah, can you blow that up a little bit? There we go.
So we'll have launch apogee where the nose cone pops off. The payload is attached about I think it's 5 feet right now from the tip of the nose cone to of shock cord to where the payload's located in the drogue, and then the remaining cord running to the avionics bay. And then once it hits where the main is deployed, the tender descender will go off, causing the payload to be separated. The main will come out of the section between the lower airframe and the upper airframe, and then they'll land separately.
Okay, this is like, let's discuss payload. Okay, first of all, thank you for the picture. That helps a lot. Can you tell me at event 3 on that diagram, how the payload is attached to the is it attached to the parachute? Is it on a little loop, or just how is that? And then is it hung by 5 feet?
Yeah, so I can talk a little bit about why they prep it. There's an eye bolt on top of the payload. That eye bolt will have a carabiner where the drogue parachute is attached to it.
Can we take Mike's video or show it?
Yeah.
So we
AJ,
can.
do you want to talk about it since it will cut my video off? It'll cut the video off.
Ben is
There we
right there.
go. Perfect.
Yeah, so the way that this is connected, and I know that these all threads are a little long, they'll be cut down. We just had changed our model where this section got a lot shorter. But it's just connected. Oh, come on. I think you put it on there.
And it's the other side that goes on there.
Oh, it's that side, okay. Yeah, but we have the tender descender here, and that's what allows for the separation of the lander.
Okay, where is the electronics that controls the tender descender?
That becomes the chute for the lander.
AJ, they're wondering where the electronics, the wiring to cause the tender descender to separate is located at. Can you show them that?
Yes. So our L3 flyer of record has had experience in the past trying to do this, and what he's done and what we're hoping to do is we have a wire running inside of the Kevlar tubing. It's So it's running inside up to the connection point. Here, actually. Okay, stay there. So we have a quick link here, which isn't shown. It's on the lander right now. But the wires then run up over to the tender descender, and there's a large excess of wires right now. Just because we haven't wired that up. This is just spare in case we needed to lengthen something. But yeah, so
That's okay.
okay.
Yeah.
And so
But
how long is that that shock cord right there that you're
Up to
playing
this
with
point
now?
with the drogue,
Yes.
I just measured it, and it is currently 16 feet up to this point.
Okay, well, how about, what is the total length of that shock cord up to the
Up to the
cone?
nose cone, that is 25 feet total.
So this is the one that we'll have to increase the length for.
Okay, so where is the nose cone on this? Is it? Well, no, okay, it's there. All right.
Yeah, and this is where it will be separating this white band here. This is where it will be separating. This lower portion will be staying with the electronics bay. One thing that we do want to note that we have not done yet, but we are planning on doing from our last year, looking at from down in Las Cruces, we know that any point where the shock cord will be rubbing on an edge or a surface, we need to put some sort of protection, whether that's duct tape or yeah, we were planning on using duct tape. It's what we used last year to protect the shock cord from rubbing.
Okay. That's, yeah, okay. I guess, make sure I'm on, yeah. Here's my concern. Okay, first of all, I have a concern about running the wires the way you are, but I know people have done it and people have been successful, so it is what it is. My concern is the payload hanging off of there, coming down and getting all twisted up with the shock cord and everything, and not being able to do its thing, not being able to be released.
Okay. We understand that concern. We feel that it is valid. As a team, we've determined that if the payload's not able to be deployed, it's not a critical failure for the mission. Just with our
All of the tests that we've done have been really successful. So we're
What kind of test?
gonna work.
What kind of
Yeah.
test have you done?
Oh,
yeah.
Have you done a subscale test?
No,
No.
so that's my misunderstanding. I was under the impression that we had done the test for the tender descender.
Yeah, we've tested that the tender descender will separate, but the twisting of the payload inside of the shock cords is something that we don't have the funds to be able to test. We can't do a test launch due to how we're barely scraping it together enough for the motor as it is. But
Okay.
yeah.
Okay. And I assume that the main that you have, if the payload is not separated, what's the descent rate under the main with the payload dangling?
It only goes up by a couple feet, so it'll be actually like only like I think it's like 19 something feet per second when I ran it in open rocket and in RAS Aero without the weight of the rocket, that 8.8 pounds disappearing from the rocket.
Okay, good, great. Okay, now let me ask the other question, which is that, okay, let's assume you do have successful payload separation. That means this 8.5 pound mass is falling straight down, correct? With no guide.
It is with the it has the drogue parachute with it. Let's go show that.
Okay, okay, then you need to walk, I don't remember seeing that in the document, and then you need to walk me through that.
We can go back to the graphic to explain that.
We want to just show it on the.
Okay,
No, he's got it shared.
Oh, okay.
So the drogue will be the tender center will be, I believe, detonated from the altimeter, correct, AJ?
Yes.
Run off of the main altimeter. When the main altimeter causes the separation event for the main parachute, it will cause the tender center to separate the drogue and the payload, which are connected together with the carabiner, to go off on its own while the main is being deployed. That separation event is happening.
okay, so in summary, the payload will fall under a parachute, and then quote, land or whatever it needs to do, correct?
Yes.
Perfect. Okay, I don't think that was in your original, but that's okay.
Oh, okay. Our bad.
That's why we're doing this. That's exactly why we're doing this. Okay, that you've cleared up the questions I had from going back and reviewing things. I'm not concerned about the motor. I'm not really concerned about the rocket. I was concerned about payload and how it was going to be deployed. So on that end of it, I do think you have a reasonable chance of tangling. Things get real wild up there, as things go, and you don't have much control over it, but you know, it is what it is, I guess. I don't know of any other way any good ways to prevent some of that from happening, unless either Leo or Elaine has some comments. I mean, Leo, I keep calling you Leo. Lee.
That's all right. That's how I sign it. So, my only thought was on the wire running through the Kevlar cord. I think you said your L3 advisor is having some experience in this, working with it. How much excess wire do you have on each of these? Specifically, does that Kevlar cord stretch a little bit? And if you have very little, if you only have a couple of inches of electrical wire, will it stretch to the point where it actually pulls it out of a connection? So my question is, how much excess wire do you have after it leaves the Kevlar cord until it goes to its electronic unit that it's attached to?
We currently have 4 feet spooled up on one end. We are planning on having at least 10 inches on either side. The shock cord is not very flexible. It's not very it's stretched.
Yeah, it
Yeah, not
doesn't
very
give very
elastic.
much.
Yeah, and I know it's not elastic, but when you have that much, I didn't know if it ends up pulling about, an inch or two. And if you cut it right to the limit, like, again, the guy that your advisor's got some experience in this, just want to make sure you didn't, no pun intended, cut yourself short.
Yeah, no, good pun, even if it was not intended. We have not, we have quite a bit of space here, and we're planning on having 10 inches on either side to accommodate for any extra stretching or something getting pulled one direction or not. Yeah.
Okay, thanks.
So I'm the L3 Greg, and my experience is I wouldn't probably put 10 inches because then I get a little more worried about tangling. My guess is with that length of cord, 1 or 2 inches is going to be way more than you need because that Kevlar stuff does not stretch. Okay. That's part of the problem with it is it doesn't stretch. And so that would be I'm going to let them decide what to do, but my advice would be to have 1 or 2 inches of service loop at the ends to do what you're worried about. Because I agree that you want to have some ability to move inside that tube without pulling things loose.
Okay, thank you, Greg.
Okay. Did we, for recovery at drogue or apogee, are you using black powder charges?
We are using black powder charges.
Okay.
I know you had some concerns about that. And the way we're detonating them, and I guess Greg, we're going off of Greg's word here. We use a black tubing. I think AJ can grab it. that we put the black powder in, and so when the black powder charge is detonating, it waits until it can burst this rubber tubing, and then in Greg's experience, it detonates all of the black powder. So AJ can talk and show that.
Yeah, so this is an example charge. All of the grains are contained inside of this. The zip ties also contain like some air with it. The electronic matches and everything are kept inside of it. When it's triggered, it ruptures the tubing and allows it to pop and fill the space and pop the nose cone.
Okay, what kind of tubing is that?
The
Greg, do you know what kind of tubing that is?
I do not. We'd have to look, but I've done probably, I don't know, 50 of these. And
With that particular tubing?
it's the same rubber, if that's what you're asking. And as I recall, they're using the same diameter, so it has about the same burst strength. So I'm pretty confident that the burning of the black powder will complete, if that's what you're worried about, at 30,000 feet.
The answer is yes, and it sounds like you got it covered based on everything I've been doing. You know, I was just curious what the rubber was for my information more than anything. I mean,
AJ, I believe the new pack.
Because people basically use surgical tubing or something like that for those.
That's what it is.
You know.
Yeah, it's
That's what it is.
It's latex rubber.
Okay.
Yeah.
Okay.
Oh, by the way, I'm the faculty advisor, Kelly Wilson.
Okay, thank you.
Mhm.
Okay. If Elaine doesn't have any more questions and Lee doesn't, I did it right, doesn't have any questions.
I got one more. Did we talk about swivels and locations?
swivels.
Swivel.
Just so when you have a spinning body, it doesn't unscrew any
Tangle
bolts
up
that
your
you may have the
cords.
way they're mounted. Yeah.
Last year, any of our bolt connections, we used what is that stuff called? Loctite.
Loctite.
Yeah, we do have two eye bolts located in to secure our shock cords. One on the motor casing that's exposed right now, and the other on the nose cone. We're planning on Loctiting this. On our Avionics Bay, we have U-bolts, and so they won't. They're not at risk at being unscrewed due to any swivels or twist.
Well,
All
how
right.
about on your
I-
parachutes? Usually we see, a lot of times we see swivels on the parachute so that as it spins, as the rocket spins underneath the parachute, you don't accidentally reef up your shroud lines.
Okay. That's a good idea.
Yeah, the swivel's been called out in some of the literature out there. So I don't know if that's specifically something they might look for.
Okay.
when the chicks
Yes,
get
it's
there.
something to look for.
Okay, we're currently using quick links, but we can look for some swivels.
Is that a new requirement?
No.
We didn't
Okay.
hear that last year. Okay.
I mean, swivels are a good idea. They're not a requirement, or you don't have to have them. They are a good idea to help prevent tangling and swinging. Like, again, my main concern with this whole thing is hanging the payload under the drogue and watching it fall for 25,000 feet and not getting tangled up.
Oh yeah, that's yeah. That's the most
So,
likely
I mean,
bad thing.
whether you're using swivels or not, yeah, and in fact, Elaine mentioned something. Can you show us on your body tubes where your switches are and what kind of switches?
That's gonna be inside the electronics bay, but we can show the holes, right?
It's not in this section, it's in the other section.
Oh, okay.
Hey, Greg, I'm glad you were able to attend.
On me. Go to the red
Yeah,
spot.
I'm learning this as well. I'm trying to develop some sense of just what the requirements are, so I don't we don't get there and then find out that we didn't do something right. So
Yes, yeah.
And,
this
and
is
that's the
this is a
purpose of
great.
these video things. We haven't done them in the past, but they're so that you don't get there and find out that there was something that prevents you from flying that we could have caught earlier.
Yeah.
And I think this is a great addition because last year when we went the first time, it was completely unknown to us, and we had panics to address the problems you all found. And so this is a way better process. I'm definitely in favor of this discussion.
Okay, great. I guess you mentioned you had 10-inch couplers. Are you using a switch band?
I'm sorry, could you repeat that?
Okay. Are you okay? Your electronics bay is contained in a 10-inch coupler.
Yes.
Are you using a switch band?
I'm not
Switch
sure
band?
they will know what that means.
Oh, okay. A switch band is a little piece of airframe, usually 1 to 2 inches in length.
Oh,
That's on top. That's over the eBay, and you usually mount your switch holes through that. You don't have
no,
to.
we are not. We're not using a switch band. That sounds like a very fantastic idea, and we may incorporate that in the future.
Okay. If you do, they make sure that you account for the length of the switch band when you calculate the length of the coupler.
Okay.
Yeah.
Yeah, so currently we are just this is what we used on our 10K. We just had the holes of our electronics bay go right through the side of the rocket body. So this is one hole, and it lines up. So our electronics are currently outside of the avionics bay. We have the avionics bay, which is distributing the force through all threads. These are quarter inch 20 all threads. And yeah, so the switches that we were using are Missile Works 632 screw switches. And that's how we're accessing them. We have a switch for our GPS and switches for each of our altimeters.
Okay. And how are you holding your batteries in place?
The batteries are held in place through this side slot. That's where our alkaline 9-volt batteries go for our altimeters. Our LiPo battery is held back here,
Okay.
and it is sandwiched by another flat piece. When this is inside the coupler, the 9-volt batteries aren't able to make contact with the electronics, and they have spare wiring so that if they do move, they won't accidentally yank themselves out of the sockets.
Okay. All right. Okay, so just another nit that they'll pick in Santa Cruz is make sure that your coupler extends in 5 inches. So.
Okay. We have done
And
so.
it should.
Yeah.
Okay. All right. Sorry about that. Flip the tables around and let you guys ask any questions of us.
So I guess I have one. You're worried about tangling. Do you have any suggestions on things that we might do to make it a little less likely?
Yeah, swivels.
Any other ones?
Yeah.
How do you confine your recovery harness when you prep the rocket? Do you band fold it and secure it with rubber bands or a piece of tape, or is there anything that you do to keep the shock cord from tangling up on itself when you pack it?
We use masking tape, and we tape it
Okay.
in sections to help it unspool properly.
So do
I
you have
think-
any that are taped that you can show her?
Yes.
The main one does.
So these are taped in spooled sections, and then we spool the entire thing inside of the rocket body. What this allows is a little bit of absorption when the parachute pulls, so it doesn't completely jar the rocket. Now we used this on our 10K rocket last year, and for all of our tests, and we've had reasonable success for it. Just when a force is applied on the opposite side, it either pulls through the tape or, like with this case, it'll probably rip it. But yeah, it's not that much force to overcome the tape.
Okay, and that works really well for the recovery harness. But did you have any other plans for keeping your shroud lines on your parachute from getting tangling? And this is what we use the swivel for.
Okay. Well, we are thinking of the swivel now.
Okay.
Our parachutes are folded. This is just temporary for testing. We're not planning on putting blue tape on our parachute when we fly. This was just to keep it together while we were testing. But the entire thing has the shock cord spooled in here, and as you can see, as I pull it, our shroud lines come out easily.
The problem that I'm thinking of, though, I'm glad that it pulls out easily. That's good to see. However, when it's hanging down, when the rocket is hanging down off the parachute, it has a tendency to spin.
Okay.
So
yeah.
that's what the swivel is for, to keep it from, you know, spinning the recovery the shroud lines, so that what you end up with is a very small parachute, that, you know, or a parachute that's been reefed a lot. And I don't know didn't catch how heavy the rocket is, but you probably don't want it landing down on a much smaller parachute.
No, yeah.
Okay, we will look into getting a swivel or how
Okay.
to prevent that.
Okay,
So
sounds like a plan.
Yeah, but back, back to Greg's question. I don't have a good solution at all for dangling the payload down and not getting it tangled up. Unfortunately, I don't know if lengthening the cord makes any difference or shortening it makes any difference. You know,
okay.
sorry, I just don't.
Thank
That
you. We
doesn't
thought
mean, now, guys, you know, that doesn't mean that it won't work. Okay, it's just a consideration. So, any other questions of us? Like, I guess a couple of the team members have been to Santa Cruz, so you know what the launch site is like and the environment and all that sort of stuff. So,
Is it going to rain again?
Good question.
you know, yeah, I will share something with you, an internal thing. One of the guys that's on one of the committees is already looking at a 30-day forecast. Now, 30-day forecast says rain. How many people believe a 30-day forecast is going to show us rain? You know? So I honestly don't know the answer to that. Ask me that the week we start traveling. You know, everybody's hoping and praying that it doesn't rain. So.
Okay, I think that was my only question. So thank you guys for your time.
I just have a brief clarification. On the shock cord length, did we still determine that the one from the nose cone to the electronics bay needs to be 30 feet? Was that the discussion? Just want to clarify that.
Yeah.
Yeah.
Well,
Okay.
Yeah.
Okay. All right.
Make sure that on the nose cone side.
Okay.
And the number of swivels that we're looking for, are we trying to put swivels everywhere there's a parachute coming out?
Well, you've got 2 parachutes.
Correct.
So yeah, one on each parachute.
Okay.
Thank you.
Okay. Again, I'm good. I will see you guys in New Mexico.
Thank you for your time, and thank you for running.
Thank you.
And thank you for your time.
Have a good afternoon.
You guys
Thank
too.
you.
Yeah, thanks again.
You're
Mhm.
welcome, Greg. Looking forward to meeting you.
Yeah.